Hi, hello and welcome. In this occasion, I would like to present about license plate recognition using convolution neural network for outdoor area. It is written by myself, Fikri Nurkari Priyambodo. So, the research background for this license plate recognition are that a development of smart city can be said to have come from the improvement of technology that contributes in the quality of citizen welfare, right? And one of it is the license plate recognition, or in short, LPR. LPR can be implemented in many practical applications such as automatic toll collection, traffic law enforcement, and private space access control, and many more. And it's also used for the development of intelligent transportation systems. The detection of license plate have become an important issue. But there are numerous problems in creating an LPR that researchers have been trying to solve. The major problem is to create a detector that can be used in outdoor area with high accuracy value. By creating a system that can solve this problem, it may be proven to be difficult, but there are already multiple systems that can be used in real time and high accuracy. But when it implemented in outdoor area, the accuracy decreased. And another problem would be lighting within the image. This may cause the detector to get false positive result, since lighting can be affected by the environment easily, such as bad weather and nighttime, or by the system itself, such as bad camera in low light. All these problems may cause interruption in the LPR accuracy. So the research problem is this research discuss about a better way to recognize a license plate for outdoor area, where brightness and noises become the main problem for the researcher to recognize the license plate. Because of these problems, a system with high accuracy and high rate of mean average precision in any condition is needed. And then the research objective is this implementation is to be able to design an effective method for license plate recognition in outdoor area using the cutting edge detection and convolution neural network that will be increase the accuracy. And the research scope for this research are: we will use FMI CCTV camera located in the FMI security post entrance, which therefore we will be training using the data from the specified location of the FMI CCTV. This is basically to maintain consistency. Due to the location of the implementation, the camera used will be in a fixed position. So any research will start from the theoretical basis. So for this research, there are some of theoretical basis that it is important to know first before we continue. The first one is the histogram equalization. Histogram equalization is a gray level transformation method that forces the transformed gray level to spread over the entire intensity range. The HE, in short, adjusted image intensity to enhance contrast. So basically, histogram equalization is to enhance the contrast of the image. So as we can see from here, there's an original image which is kind of gray and not clear, right? And then after we apply the histogram equalization, it will enhance the image and making it more contrast, so that we can see the gray part, some of the gray part from the original image. As we can see, there is an Elvis Presley from the transformed image. So histogram equalization is part of an important theoretical basis for this research. As I said before, that license plate recognition in outdoor area sometimes affected by the environment, such as bad weather and many else. This is according Reddy et al. From 2017. The histogram equalization is the intensity levels are changed such as that the peaks of the histogram are stretched and the troughs are compressed. Next is the Gaussian filter. Gaussian filter is included in a linear type filter with a weight value for each pixel set in it by using the Gaussian function. The Gaussian filter is used to blur image and remove unwanted detail and noise. The linear process in the Gaussian filter is done by multiplying each adjacent neighbor pixel and summing the result so that it gets the result for a certain coordinate point. The mechanism of the linear spatial filter is to move the center of a filter mask from one point to another. In each pixel, the result of the filter at that point is the sum of the multiplication of the filter coefficients and the corresponding neighbor pixel in the filter mask range, according to Putra et al. At 2017. So, to make this simple, is Gaussian filters is a linear type filter with a weight value for each pixel, and the implementation are it makes the image, the original image, be blurred in some of the area and remove unwanted detail and noise. As you can see from the picture beside it, shown it, the original one is full with noise and detail, right? So by applying Gaussian filter, it will remove the unwanted detail and noise. So we basically get the image that we want as the image that we really want. Okay, so it is creating a new model for the image. Just like to imagine it that we just want the shadow of it, to make it simple. And then we are going to use Otsu's method. So why do we use Otsu's method? Because it involves iterating through all the possible threshold values and calculating the measure of spread for the pixel levels each side of the threshold. The aim is to find the threshold value where the sum of foreground and background spread is at its minimum. Otsu's method works based on the very simple idea that minimizes the weight within class variance. Otsu's algorithm will consider some assumptions such as the input image is bimodal, uniform illumination, and etc. This is according Reddy et al. 2017. So, to imagine Otsu's method is like imagine yourself in a racing sport such as maybe F1 or MotoGP, that you are going to race and finding your best lap, right? So the iteration means that you are going to the same track over and over again, maybe for like 20 laps. And then from each lap it will be timed, right? Time of your best time for achieving one lap, and the smallest number of time for finishing each lap is the fastest lap, right? So it's similar with the Otsu's method. It is to finding the minimum value of threshold value after the sum of foreground and the background. Next is the canny edge detection. Canny edge detector is an edge detection operator that uses a multi-stage algorithm to detect a wide range of edges in image. Canny algorithms smooth the image by Gaussian filter, calculate the magnitude and direction of gray level gradient, which has the non-maximum suppression on gradient magnitude, and detects and connects the edge from the candidate points by the high and low threshold. Canny algorithm finds the image gradient to highlight region with high spatial derivative. It will be explained from the process, so I don't really think that to make it simple, that canny edge detection is finding the to make a, like its name, to make an edge detection. So it is an edge detector to find the boundaries of the image. So which one is the top boundaries, left, right, or bottom boundaries, right? So by finding the highest value, it is immediately classified as edge. So the process of canny edge detector algorithm is as follows, according to Fang. First one is smoothing. Smoothing is by blurring of the image to remove noise by convolving the image with the Gaussian filter, as I shown before. And then finding the intensity of gradient of the image. The edge will be marked where the gradient of the image has large magnitudes. Finding the gradient of the image by feeding the smoothing image through a convolution operation with the derivative of the Gaussian in both the vertical and horizontal directions. And then third one is non-maximum suppression. Its only local maximum should be marked as edge. And the double thresholding. So potential edge are determined by thresholding. Instead of using a single static threshold value for the entire image, the canny algorithm introduces hysteresis thresholding, which has some adaptively to the local content of the image. There are two threshold levels, high and low values, where the pixel values above the high value are immediately classified as edge, as I mentioned before. Final edges are determined by suppressing all edges that are not connected to a very strong edge. This is edge tracking by hysteresis. The next one is artificial neural network. So ANN is a computational model that was inspired by the neurological connection within a biological brain. The model consists of simple connections called neurons. The neurons send signal at spikes of electrical activity through long-thin strands known as axon and axon splits. This signal through synapse and send it to the other neurons. A neural network can be trained to perform a particular function by adjusting the values of the connection between elements, according to Tur. And then the activation function. An activation function is a function within the neurons that takes its inputs and defines its output. There are multiple activation functions such as the sigmoid function, tan h, and rectified linear unit, and etc. Activation functions are used to convert the input signal into an output signal and converting it from linear. And then stochastic gradient descent. Gradient descent is an optimization algorithm that can be used to minimize a function. In a neural network, this function is the cost function of the model. This cost function represents the error of the neural network model, and gradient descent performs the optimization by applying small change to the weights and gradually minimizing the cost function. The gradient or the rate of change of the cost function can be obtained by deriving the cost function and renew the new weight of the neural network with every iteration. However, calculating the derivative for every data can be computationally expensive, and therefore the stochastic gradient descent is used. Unlike traditional gradient descent where every data is used to renew the weight, the sum of the gradient for a batch of data is used to update the weights, according to Hansen and Olson. And last are convolution neural network. Convolution neural network, also known as CNN, is a form of artificial neural network. It consists of an input layer which takes in an image of different dimensional matrix as the input, a hidden layer which consists of three types of layer: convolutional layer, the pooling layer, the rectified linear unit layer, and lastly the classifying layer, which is an optional layer as the hidden layer, and the last type of layer, the output layer, which produces the result of the CNN, according to Johnson and Karpathy in 2015. Unlike an artificial neural network that uses weight in the synapse, in CNN it uses filters applied on the input matrix. Filter is a matrix that contains adjustable values that are used to extract the features on the matrix into the next layer. A CNN can have different architecture design which consists of different order of the different types of layers within the hidden layer, different filter size and properties of each layer. By having different layers in the hidden layer, it can affect the unique result obtained from the CNN. And now we're going to see the research methodology. So the location of it is FMIPA UGM, and the population is the FMIPA UGM visitor. The data sample is the license plate FMIPA UGM's visitors. So to better understand this, I created this research flow. So at first we are going to create or obtain a CNN model, okay, and then we're going to get data acquisition. The data acquisition is done by capturing the image from FMIPA UGM CCTV and from the FMIPA UGM CCTV, and then it's going to the server and we obtain the footage, right? So after we get the data, we'll proceed into the enhancements and segmentation process. The principal objective of the enhancement is to process an image so that the result is more suitable than the original image for a specific application. And then I'm sorry. And then the new size image then converted into grayscale to simplify the enhancement process, because it only contains two main colors, black and white. The histogram equalization is applied to normalize the pixel values of the grayscale image. HE, in short, makes the bright image darker and the dark image brighter. The image occasionally will have many noise, but it will have many noises which will disturb the segmentation process, right? So the deficiency of the segmentation process will be prevented by applying the Gaussian filter. The Gaussian filter that will be used is the Gaussian low pass filter, which will make the image become blurred, reducing the detail of the image, according to Makender and Halili. halali. The result of the Gaussian low-pass filter is bokeh effect, where only the vehicle's plate becomes, the vehicle's plate object becomes blurred. The segmentation aims to classify the background pixels and the foreground pixel. The segmentation will first separate the dark pixel and the white pixel by applying Otsu's thresholding method after Gaussian low-pass filter is applied, to make the Otsu's thresholding method become efficient. The separation is used to detect the plate which will have white pixel. The Otsu's method is applied to replace the double thresholding method from traditional canny edge detection threshold method. According to Hatem 2013, he mentioned that Otsu method is the best method of selecting an optimal threshold value automatically by the discriminant criterion. The Otsu thresholding method will make the image has two colors, black and white, where the white colors from the high pixel value object and the black color from the low pixel value object. The canny edge detector will detect the edge of each character from the license plate which wants to be recognized. Okay. I'm sorry about that. So next is that each character will be recognized by using CNN method for the better result, and then the CNN I'm sorry. So the CNN will be used in recognition process to detect each character on the vehicle's plate. The image after segmentation process will be used as input. The CNN architecture will use ReLU as activation function to transform the input into positive value, which will activate the neurons, or zero value, which it will not activate the neurons. And then we are going to evaluate enhancement and segmentation process and the CNN model. And then after that we are going to save the evaluation records. So after all models have been evaluated, do we get the result that we want? If not, then we are going back to test the different model, the CNN model, and if it is yes, then we can print the best model. So that is basically what my research proposal and research flow is all about. So thank you for your attention, and I'm sorry if I go sometimes in the presentation because I'm not really fit through today, and I'm sorry if there is a word mistakenly spoken and pronounced it. So I'm Fikri Nugari Prondo, and thank you for your attention.